Hey there, Algebra 2 students. Welcome back to class. I'm Miss McGuire, and today's lesson is all about parallel and perpendicular lines. Today we're doing Unit 1, Lesson 9, and our objective is I will identify if lines are parallel or perpendicular and explain how I know. So before we get started on identifying if lines are parallel or perpendicular, we need to understand what in the world those words even mean. What are parallel lines? What are perpendicular lines? So let's go ahead and jump right in. First, make sure that you have your first and last name, period, and the date in the top right-hand corner of your notes. And of course, make sure you're writing everything down as we go. So let's talk about parallel lines. Well, parallel lines are lines that never intersect. So they are lines that never intersect. And they have to be independent lines. So at least two lines, there could be more than two lines though, that are completely independent of each other and never intersect for as long as they extend into infinity and negative infinity. So for example, in this picture here, we've got two lines. And these two lines are two separate lines. They're independent of each other and they will never intersect. And they're parallel. The thing that makes them parallel is their slope. They have the exact same rate of change or slope. So they have the same slope. And we can also refer to slope as rate of change. So slope, also known as rate of change. But they have to have different y-intercepts. Because if they have the same y-intercepts, they'd be the same line. So our parallel lines have different y-intercepts, but they have the same slope, which means that they will never intersect. So if we look at these two equations, let's see if we can find the slope real quick. So for line 1, the slope, I'm going to use these 2 points. It looks like we go up 1 over 2. So the slope of line 1, or slope 1, is equal to 1 over 2. Then the slope of line 2, I'm going to use these 2 points. It looks like they go up 1 and over 2. So the slope of line 2 is, or slope 2, is also 1 over 2. And they're the same. Which means that those two lines are never going to intersect. Let's move on to perpendicular lines. So for perpendicular lines are lines that intersect at a 90-degree or a right angle. So they are lines that intersect at a 90-degree angle. All right. So parallel lines have the same slope. Perpendicular lines can't have the same slope because then they would never intersect. And to be perpendicular, we need them to intersect. So perpendicular lines have slopes that are opposite reciprocals. Opposite reciprocals. So what that means is if you have a fraction, I'm going to make some notes about opposite reciprocals off to the side. So here are examples of opposite reciprocals. So let's say you have 1/2. The opposite reciprocal, the opposite part means that the sign has to be opposite. So 1/2 is positive, so its opposite would be negative. And then a reciprocal just simply means to flip the fraction. So you would flip it to 2 over 1 or just 2. So 2 over 1, negative 2 divided by 1 is the same thing as just negative 2. So what about negative 3? Well, the opposite of -3 would be positive. Then technically 3 is over 1, so if I flip that fraction, I would have 1 over 3. So the opposite reciprocal of -3 is positive 1/3. What about 1? Well, the opposite of a positive 1 would have to be negative. And then isn't 1 technically over 1? So if I flip that, I'd still have 1 over 1. Well, what's 1 divided by 1? Just 1. So the opposite reciprocal of positive 1 is negative 1. So let's talk about this example. So in this example, we have a line that says y equals 3x minus 1, and y equals -1/3 x minus 2 is the other line. Well, as you can see, the slope of line 1 is 3. The slope of line 2 is -1/3. Well, 3 and -1/3 are opposite reciprocals. So these are perpendicular lines, and we know that these two lines intersect at that 90-degree angle. That point right there where those two lines intersect is called the point of intersection. Point of intersection. So perpendicular lines always have a point of intersection, and that point happens at a 90-degree angle. All right, so that's a little bit about parallel lines and perpendicular lines. So let's talk about some examples. So in example 1, we've got a whole bunch of pairs of lines. And what we need to determine is, are these lines parallel, perpendicular, or neither? And then how do we know? Well, if you look at line 1 in the first part of our example here, line 1 has a slope, so M1, our first slope, is -2. Then the slope of line 2 in y equals 1/4 x minus 2 is 1/4. Well, these slopes are not the same, and they're also not opposite reciprocals. The opposite reciprocal of -2 would be positive 1/2, and the opposite reciprocal of 1/4 would be -4. So these also aren't perpendicular lines. So that means that these lines are neither parallel nor perpendicular. So we're going to say these lines are not parallel nor perpendicular because the slopes are not the same nor opposite reciprocals. So let's talk about the next example together. So we have line 1, y equals x minus 5, and line 2, -x plus y equals 4. So line 1 is in slope-intercept form. It's in y equals mx plus b form. I can easily tell what the slope of line 1 is. Line 1 has a slope of 1, because technically there's a 1 being multiplied by that x. Well, line 2 is in standard form. So I'm going to switch it to slope-intercept form by simply adding the x to both sides. So y is equal to x plus 4. Now I can easily tell the slope of this line. The slope of the second line is equal to 1 as well. Well, the slopes are the same. So that means that we have parallel lines. So these lines are parallel because the slopes are the same. All right, go ahead and do the next two examples on your own, and then check your answer with mine after you do yours. So line 1 is x plus 3y equals 9, and line 2 is y equals x plus 4. So as you can see with my work, line 1 needed to be rearranged so that it could be in slope-intercept form. So I solved for y in line 1, and I got y is equal to negative 1/3 x plus 3. So I can tell that the slope of line 1, or m1, is equal to negative 1/3. Then the slope of line 2 is 1. So these lines are neither parallel nor perpendicular because the slopes are not the same, nor are they opposite reciprocals. Let's move on to the next example. So for the next example, use line 1 as negative 3x plus 4 equals y, and line 2 as y equals negative 4/3 x plus 1. So the first thing I did was solve for y in the first equation, and I got y equals 3/4 x plus 2. So the slope of line 1 is 3/4. The slope of line 2 is negative 4/3. Those two fractions are opposite reciprocals of each other. Therefore, we have perpendicular lines. In example 2, we are given an equation of a line and a point that's on a different line. We need to write an equation that is parallel to the given line and contains the given point. So in this first one, we are given y equals 3x minus 4 and the point negative 3, 2. So y equals 3x minus 4 is our line 1. We need to find line 2. Well, the key word in our directions is that our line 2 needs to be parallel to line 1. Well, what do we know parallel lines have? Parallel lines have the same slope. So if line 1 and line 2 are parallel, then they must have the same slope. So in y equals 3x minus 4, our slope is 3. So we're going to use a slope of 3, and we're going to use the point negative 3, 2. Well, if I have a point and I have the slope, I'm going to write an equation in the form of point-slope form. So I have y is equal to, and actually off to the side real quick, I'm just going to remind us what point-slope form is. Point-slope form is y is equal to m times x minus h plus k. So negative 3 would be our h, 2 would be our k. So we have y is equal to our m, 3, times x minus h, which is minus a negative 3, and then plus k, which is 2. So y is equal to 3 times x plus 3 plus 2. And then just for fun, we're going to go ahead and put this equation into slope-intercept form. To do that, just distribute the 3. So y is equal to 3x plus 9 plus 2. So y is equal to 3x plus 11. And as you can see, line 2 has a slope of 3, line 1 has a slope of 3, and they have different y-intercepts. Therefore, we have two parallel lines. So this can be our answer. This is the equation of a line that is parallel to the first equation of the line that we were given. So let's do example 2 together, or part 2 of this example together. So line 1 in this case is y is equal to negative 4x. And again, they have to be parallel, so we're going to use the same slope. So for line 2, we're going to use m equals negative 4. And then we have the point 0, negative 8. So because we have a point and a slope, we're going to put this into point slope form. So y is equal to negative 4 times x minus 0 minus 8. Let's distribute that negative 4. Y is equal to negative 4x. Negative 4 times negative 0 is just 0. And then y is equal to negative 4x minus 8. There we go. Now it's your turn. So now I want you to write the equation of a line that's parallel to this line, y equals 1/3 x minus 4, and contains this point. Go for it. Next, I want you to write another equation of a line that's parallel to this line, y equals x minus 4, and contains this point, 7, 5. For example 3, we're going to switch it up. We're going to do the same thing, but this time we want to write the equation of a line that's perpendicular to the given line and contains the given point. So we're going to start with y equals 3x minus 4 as our first line. And then the point that line 2 contains is negative 2, 3. This time the key word is perpendicular. So for perpendicular lines, remember their slopes are opposite reciprocals. All right, so the slope of line 1 here is 3. Well, that means that for line 2, our slope would have to be negative 1/3. Because 3 is technically over 1. We want to flip that fraction and have the opposite sign. Then our point is negative 2, 3. So let's plug that into point slope form. Y is equal to negative 1/3 times x minus negative 2 plus 3. So y is equal to negative 1/3 x, and then this would become a positive 2. So a negative 1/3 times 2 would be negative 2/3, and then plus 3. And now we need to add negative 2/3 and 3. To do that, we're going to put 3 over 1, and then multiply that denominator and numerator by 3, so we have the same denominators. So y would be equal to negative 1/3 x minus 2/3 plus 9/3. So y is equal to negative 1/3 x. Negative 2 plus 9 is 7. So 7/3. So y equals negative 1/3 x plus 7/3. The next problem we're going to do together, the given line is y is equal to negative 4x, and the point on the second line is 0, negative 6. So this is line 1. The slope of line 1 is negative 4. So for line 2, we're going to take the opposite reciprocal of that for its slope, which would be positive 1/4. Then we're going to plug that slope and the given point, 0, negative 6, into point slope form. So y is equal to 1/4 times x minus 0 minus 6. Well, x minus 0 is just x. And then 1/4 times x is just 1/4 x. So y is equal to 1/4 x minus 6. And that is the equation of the second line that is perpendicular to the original line. Right, the next example I want you to do is y equals 1/3 x minus 4, and the given point is negative 6, 2. So you're going to write a line in slope-intercept form that is perpendicular to this line. Go for it. Now I want you to write the equation of a line that is perpendicular to y equals x minus 4 and contains the point 7, 5. And I want the line to be in point or slope intercept form when you're done with it. Go for it. Now, when you are in today's folder on Schoology, you're going to see that you have two things that you need to do. One is to watch this Edpuzzle for tutorial day, and the other is you have a survey that I would like you to take. So when you're done with this Edpuzzle, you're done with your notes, please go take that survey and give me as honest answers as you can. I will see you all back in class pretty soon. I hope you have a good day.